Okay guys, so right now we are solving question 2.3 and the question is, what is the total charge, Q total, on the capacitor? How much charge gain on each plate, right? So what's going on in the capacitor? If I apply some voltage, let's call it V0 here, so negatively charged from the battery would go over and accumulate over here, and here it's gonna be a build-up charge, right? But here there are gonna be some electrons which sense this electron. They cannot pass. There's a barrier here, right? This is a capacitor plate. There's nothing between this, but they're gonna feel the repulsion of this electron, and they're gonna go back to the battery. That's what the electron gonna do. So we actually have a circuit. We have a current running in our circuit, even though the circuit looks open, right? It's open, but usually this distance is super small, so the actual electron can feel the repulsion from the electron that allocate around this one, about this arrangement of the plate. So what is Q total is the question. How much charge do I have over here? And to solve this, we have a really famous equation for the capacitor, which is Q total equal to C, which is the capacitance of this capacitor. In our case, it's a plate capacitors. That's how I sign up a plate capacitor, just in our case. And multiply by V, the voltage between these two plates. So this is a really important equation, and you should remember it. And the trick for me to remember it, I think about that Q, the charge, when going to a job interview, and submit is CV, okay? We want to apply to the job, so that's the trick from me to remember it. You can do whatever you want. For me, it's working. So you're more than welcome to use it. And for a plate capacitor, you actually saw in the lecture that this one is equal to A multiply epsilon 0 of divided by D, right? And in our case, V is V0. So the general result is that the Q total, the charge gonna accumulate on each plate, it's gonna be the same, and it's gonna be V0A epsilon D. Okay? So we solved the next question, and what I want you to see that this actually, you solved it and found this one using Gauss's law in the lecture, so you should remember it, and remember this equation also. It's really important. Okay, let's go to the next question.